Okay, so here we go. So fraction bars. So we are adding fractions here, and they wanted with diagrams with these what are called fraction bars. So these are really helpful. I think these are super valuable for teaching kids when they first start learning about fractions. This is excellent tool to help them really become clear on what fractions really truly mean. Okay, so let's look at this first one right here. Right here. So this one, what portion of that fraction bar is shaded currently? So there's five parts to it, and 1/5, 1 out of 5, 1/5 of it is shaded, right? Isn't that good? How about the blue? What portion of the blue is shaded?
1 out of 4.
1/4 of it, right? 1/4 is shaded. All right, so now how do we add a fifth and a fourth? Well, you guys know how to add a fifth and a fourth. You got to get common denominators, right? If I gave you a problem out here and I said, hey, I want you to add a fifth and a fourth, you would know exactly what to do. You would multiply top and bottom by 4 on that one, and top and bottom by 5 on that one, right? You would share the other denominator, in other words, right? You would multiply by the other denominator, right? The 5 went there, and the 4 went there, right? That's what you would do, and you're right. And then that would become 4/20ths and 5/20ths, so that we could then add them and get 9/20ths. Exactly. Well, we're trying to show all that with these fraction bars so that it's not just mechanical steps, but it really makes sense to people. So here's what they did. How did they get, so this is step number 1. How did they get down here to step number 2? Well, they basically took step 1 and they shared the bars. What do I mean? So just like we take the 5 and we multiply top and bottom by 5, and we take the 4 and we multiply top and bottom by 4, right? We share the denominator. That's what they did. They said, hey, just take these bars over to this guy. So they took these sideways bars, and they went like that, and like that, and like that. And then they took this guy's bars, right, and said, oh yeah, move his bars over there too. So we said, oh, okay. So we've got 1, 2, 3, 4 bars there. So we got a bar here, a bar there, and a bar there. And you see, that's what they did. That's how they got this diagram and that diagram. And why do they do that? Because then that makes all the boxes the same size. See how this box and this box and this box and that box and that box are all the same size little boxes, right? We call that common denominator. That's a picture of what a common denominator really is. Whereas up here, the bars were not the bars were not the same size, right? Originally, before I put those lines in, the bars were not the same size. Let me go back. Oops. Now, before I put these extra bars in, right? This was 1/4 right here, and this is 1/5. That's not the same size. So the bars were not the same size originally, but then we share each other's lines with the other one, and they all become the same size. Common denominator. That's what you're really doing when you make a common denominator. That's a picture of it. Now, why do you care to do that? Well, because then it's easy to add them. Now there's no mystery how to add this. What is this first shaded section? Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now there's 20 total, so that's 4 out of 20 are shaded. The shaded portion is now clearly 4/20, isn't it? And what about the blue? What portion of the blue is shaded?
Five twentieths of it.
Yeah, exactly. So the blue is clearly 5/20. See, that's what we got here, 4/20 and 5/20. 5/20 of the blue. And now we can just add the 5 and the 4, can't we? Because now we're talking about the same kind of boxes. We couldn't do that with the original question, 1/5 plus 1/4. We couldn't just, because kids will ask you, and I hope they will. It's a great question. Why can't we just add like that? Why can't we just add the 1 and the 1 to get 2 and add the 5 and the 4 to get 9? It's a great question. And it's so good to ask questions. Why can't we just do that? Well, the reason is because they're not the same size boxes, right? Look back here. We can't just say, we can't just look at this and go, one of these boxes and one of those boxes is 2 boxes. Well, those are 2 different size boxes, aren't they? They're not the same. But if you share the lines with each other and make common denominator, now you have the same size little boxes. So now you can add them. Now you can say, 4 of these boxes and 5 of these boxes make 9 of those little boxes, and they're all the same size out of 20. So they ask here, how many equal shaded pieces are there? There are 9 shaded pieces. How many pieces in the one whole square? 20. And then what is the sum of the fractions? 9/20. So there we go. It's just a nice picture of why we need to get a common denominator when we add fractions, because you got to make the little boxes all the same size in order to add them. You can't add different size things. It's like apples and oranges, like the old saying, right? You can't add apples and oranges. You can't add different boxes that are different sizes. You've got to make all the boxes the same sizes by sharing the lines with each other. Share the lines with each other and all the boxes become the same size and you can add them. Is that good? Questions on that one?